Good day, everyone. So this video is a continuation of what we were doing with respect to add maths on the integration worksheet. Okay, so let's take a look at the questions. So we have part C tells us a curve which has a gradient of dy dx equal 3x minus 1 passes through a point A for 1, find the equation of the curve. So to get the equation of the curve, we integrate. So we could get dy is equal to 3x minus 1 dx. So we integrate both sides. Notice here we don't have any limits. So if we integrate dy, we get y. We can ignore the constant of integration on this side, and we will just put one constant on the right-hand side. So integrating 3x, we get 3 over 2 x squared minus x plus our constant of integration. Now this is the general curve. We want to find a curve that specifically passes through this point 4, 1. So we have to put, wherever we see x, we put 4, wherever we see y, we put 1, and solve for c. So we have 1 is equal to 3 over 2 times 4 squared minus 4 plus c. So we have 1 is equal to 4 squared is 16, 16 over 2 is 8, 3 8s are 24, minus 4 plus c. So we get 1 is equal to 20 plus c. So that means that c is equal to negative 19. So our function is given by y equal 3 over 2x squared minus x minus 19. And this is our curve. This question tells us a particle moves in a straight line so that the distance s in meters after t seconds measured from a fixed point O is given by the function s equal t cubed minus 2t squared plus t minus 1. So they want to know its velocity when t equal 2. So recall the definition of velocity. Velocity is the rate of change of displacement or distance. So we have velocity equal ds dt, the rate of change of distance over and of course it's with respect to time. So if we differentiate this, we get 3t squared minus 4t plus 1. That's from here using the power rule for derivative. And v at t equal 2, we get 3 by 2 squared minus 4 by 2 plus 1. This is 12 minus 8 plus 1, which is equal to 5 meters per second. Notice that we have distance in meters, time in seconds. So we have meters per second. The values of t when the particle is at rest meaning that it isn't moving. So we have our function velocity. We got that here, which is 3t squared minus 4t plus 1. All right, and we want this to be equal to 0. Notice that this could be factored as, well, we could write this as 3t squared minus 3t plus minus 1 or minus t plus 1 equals 0. You could have used a times c. The factors of that should add to give b, and you'll notice that is negative 3 and 1. Negative 1, sorry. So factorize, then we get 3t into t plus 1 minus 1 minus t into, sorry, minus 1 into t minus 1. Factorize in the t minus 1. And if we have two things multiplying to give us 0, we have two cases. either t minus 1 is equal to 0. So that means t is equal to 1 second. So at 1 second, the particle is at rest. And the other value, 3t minus 1 equals 0. So 3t is equal to 1. So that means t is equal to a third seconds. So at t equal 1 and t equal a third, we get our particles at rest. This is why we equate it to 0, so that the particle is at rest, it is not moving. Okay, so part 3 access to the distance between the rest points. So here I wrote the distance equation that was given in the question. So we could evaluate s at t equal 1 and t equal a third. Take the difference and we will get the distance between the rest points. So we have s at, let's do the third first, since it may be more difficult. So we have 1 over 3 cubed minus 2 times 1 over 3 squared plus 1/3 minus. Allow me to write this 1 as 3 over 3. Or this 1 for now. Let's write it as 1 for now. So here 1/3 cubed, we have 1 cube is 1, 3 cubed is 27, minus 1/3 squared is 1/9, so we have 2/9 here, plus 1/3 minus 1. So simplifying this, we can get everything over 27. So we have 1 minus 6, because 9 into 27 is 3. 2 times 3 is 6, plus 9. 3 into 27 is 9. 9 ones are 9. And then minus 27, because that 1 is like 1 over 1. Doing this, we get negative 23 over 27. The second one is at s equal 1. So we could get 1 cubed minus 2 by 1 plus 1 minus 1. So a few things cancel, like this positive 1 and this negative 1 will cancel. And we have 1 cubed minus 2. So 1 minus 2, it's negative 1. So our distance between the points, so our distance is like s of 1 minus s of 1/3. It's like final point minus initial point. Probably fit that here, allow me. So we'll get negative 1 minus, minus 23 over 27, negative. So that will become positive, and this will become negative 4 over 27. Now, is that distance they want, right? They want the distance between the rest points. This will be meters, but we can take the positive version, right? We can take the absolute value or the positive version to get the distance between them. So it is about 4/27 of a meter. Okay, so part 4 access, the time at which the maximum velocity occurs. Now, if you look at the velocity equation, there's no maximum for this graph because this graph goes without bound. However, the question may have a typo, because if it was minimum, if you were to plot this graph, right, if you were to plot it, you would notice our roots were at 1 and a third. So we have a root here at a third and 1 at 1. So this is a third, this is 1, and the minimum occurs somewhere around 2/3. If you were to check it, you could find that the minimum was at 2/3. So the minimum velocity is 2/3, but the velocity actually increases as time increases. So this here, no maximum exists. If you want, you could check. If you find the derivative of v, set it equal to 0. That's how we usually maximize something. You would realize that what you get is a local minimum, not a maximum. So that's the answer for part 4. And that takes us to the end of this video. So next time we will take a look at our graph question, our velocity or displacement time graph, and we would finish this worksheet. So thank you for coming. I'll see you in the next video.